Let's go through LeetCode 474, ones and zeros. So it gives us a string arrays, strs, and two integers, m and n. So return the size of the largest subset of strings such that there are at most m0 and n zeros in the subset. Take an example. One, let's say it has strings like this. And if we do not exceed m0 and n1, we can at most select 4 strings. So it return 4. Right, so this is a kind of classical backpack problem. For every string, we have the option to choose or not choose, right? So the thing is that the only thing is that the pack size, the pack capacity have 2 dimensions. One is the number of zeros, another is number of ones. So we can. So this is the classical 0-1 backpack problem. For 0-1 back problem, we just have the iterate those kind of items and also iterate the capacities, right? So we need to have 3 for loops, the length of the strings and also the length of the 0 counts and the 1 counts. So we have 3 for loop. For space, right? Of course, we can use 3-dimensional DP, right? But the thing is that we know 0-1 back problem, we can get rid of the first dimension of the item dimension, right? So we can just use the 2-dimensional space that we can have m multiple by n space complexity. Let's have this. But the thing is that in order to save one space for this kind of weight loop, we should iterate from the right to the left. So what we're going to do is that we'll say for int I equals 0, right? Actually, we can do this from 1, right? Iterate every strings I smaller than strs dot length plus 1, right? Because you can say for I equals 0 to length, right? And because this dimension actually we do not use, but if we have 3-dimensional, right? We prefer to have for example l minus plus 1, right? So this is the same as this, from 0 to its length. So it is and we'll have I plus plus, right? So we'll say for this string, str equals strs I minus 1, right? We can write a help function to get its counts, 0 counts, and 1 count. So we'll have a function for get count. And we know if we want to save one space for the 101 backpack problem. For the space, we need to iterate from the right to the left, where right for j into j equals m m, yeah, because we want to get the m, right? So j greater equal to so but this m, right, m will be number of zeros, right? So for this count zero, zero, this is zero counts, right? Zero count, and count one, it will be one count, okay? So j greater equal to this count zero, j minus minus, right? And let's say for int k equals n, k greater equal to the count one, right? Count one, the one counts a minus minus. So what we're going to do is that dp jk equals the max dot max dp jk, and also dp we that is we do not add this string. And if we in the actually this is the L minus one, right? But we save this space. That means if we have the for example I those kind of strings, right? We do not use it. But if we use it, we need to save this space. That is j minus count zero, and k minus counts one, and then we add this string, add one counts. In the end, we just return dp and right. To get this count, this will also be very easy. So we'll have a count. So this will be, let's say this is one count once, right? Once, one count equals zero. So what we're going to do is that for every chassis under str2 char string, and we are going to have one count plus equal to z minus zero, right? And in the return, new int str dot length minus one count and one count, right? This is count, not counts. The time complexity will be the length, right? This is length multiplied by m multiplied by n, and the space will be m multiplied by n.